Hi guys, today we will be looking at atomic structure. If we think of the word atom, what we are really looking at is the smallest particle of an element that can exist. So smallest, very important. Element. Now an element will consist of only one type of atom. For example, we have the element copper. Copper will consist of only copper atoms. Carbon will consist of carbon atoms. Magnesium, magnesium atoms, and so on. Now an atom is extremely small, and if we are to think of the width of an atom, it's considered to be 1.0 times 10 to the minus 8 centimeters. We have several models of the atom, and if you were to do a quick internet search, you will see a model which shows that atoms consist of protons and neutrons in the nucleus. So I have my protons, and I have my neutrons. Surrounding the nucleus will be my electrons, which are considered to be on shells or on orbitals. So I have my electrons surrounding the nucleus, and in my nucleus I have protons and neutrons. Now an atom is almost entirely empty space, with most of the mass concentrated in the nucleus. Now, so let's look at, so we have considered that an atom is the smallest particle of an element, and we have looked at the fact that in the nucleus we have protons and neutrons, and surrounding the nucleus we have electrons. Now the protons, neutrons and electrons we call these subatomic particles. Subatomic meaning they are smaller than the atom. So these are smaller than the atom. Or protons are positively charged, or neutrons, they are neutral, so they don't have a charge, and or electrons are negatively charged. Since we have the protons and the neutrons in the nucleus, so we have protons plus neutrons in the nucleus, it means that the nucleus is positively charged. So nucleus positively charged. Let's look a little closer at these three particles. The protons. So the proton, it has a mass of 1 and a charge of +1. The neutron has a mass of 1 charge 0. The electron has a mass of 1 divided by 1840, which can be considered to be almost 0, since when we divide 1 by 1840, we are going to get a very, very small number, so we can consider it to be almost 0. The charge of our electron is -1. We consider an atom to be electrically neutral since we have same number of protons and electrons. So let's look at this a little closer. Say, for example, we have a sodium atom. If you look on your periodic table, so the symbol of sodium is Na, mass number 23. So this number here is our atomic number, which gives us the number of protons in the nucleus of the atom, and it tells us the number of electrons in a neutral atom of sodium. Now looking at this, so that's 11. What this tells us is that we have 11 protons and we have 11 electrons in a neutral atom of sodium. So in other words, since the protons are positively charged, that's plus 11. Electrons are negatively charged, so that's minus 11. Plus 11 and minus 11 works out to be 0. So we consider this to be electrically neutral. Equal numbers of protons, equal number of protons and electrons. When we look at ions, this will not be the case, since for an ion we can have number of protons greater than number of electrons, or number of electrons greater than protons. So once we have protons equaling electrons, the atom will not be charged and we consider it to be electrically neutral. Alright, each atom, I touched a little on this just now, so each atom has two numbers associated with it, two numbers. For example, so we have 12, 6, carbon. This number, so the 12, we call that the mass number, and the 6, we call that the atomic number. The atomic number is the number of protons in the nucleus of an atom. How can we know the atomic number? It will be the smaller, so it's the smaller of the two numbers. Smaller of the two numbers in most periodic tables. The atomic number will tell us so it gives us the identity of an element, because we can have more than one element, more than one atom of an element having the same atomic number, but the mass number is different. We will look at those cases further on. So we have our atomic number, which is the smaller of the two, which tells us the number of protons in the nucleus of an atom. We have the mass number, so looking back at, so remember this is our example, 6 was the atomic number, 12 is what we consider to be the mass number. So it's the bigger of the two numbers. So we have the mass number, and what exactly the mass number tells us? The mass number tells us the number of protons and neutrons in the nucleus of the atom. So if I look at this, this is telling me that the total number of neutrons and protons in an atom of carbon is 12. We can have the general representation of an atom. So we have X Z A, where X is my element, A is my mass number, which gives us protons and neutrons, and Z is my atomic number, which tells me the number of protons present in the nucleus of my atom. With these two numbers, so you can be given a question to determine the number of protons, neutrons, or electrons present in an atom or an ion. If I look at, say for example, chlorine, (35). So what this is telling me is that I have 17 protons, electrons, since the atomic number also tells me the number of electrons. And if I want to find the number of neutrons, what I do is I minus my number of protons from the mass number. So number of neutrons is equal to 35 minus 17, which is equal to 18. So I have 18 neutrons. If I was to look at, for example, say chlorine 37, what you will notice here is that the atomic number is the same, but what is now different is the mass number. So I have 37 versus 35 there. Calculating number of protons, so I have 17 protons, 17 electrons, and my number of neutrons would be equal to 37 minus 17, which is equal to 20 neutrons. if you notice, the element is the same. So element is chlorine, so same element, but what is different about this is the mass number. What we call these kinds of atoms are isotopes. Isotopes are atoms of the same element with same number of protons or the same atomic number, but different number of neutrons or mass number. So what's different is the mass number or the number. So mass number different, atomic number the same, and what we call these are isotopes. So isotopes are atoms of the same element, same atomic number, but different mass number. Alright, so let's look at another example. Carbon 12, carbon 13, carbon 14. Number of protons, number of electrons, number of neutrons. Number of protons here 6, number of protons 6, number of protons 6. Number of electrons 6, electrons 6, electrons 6. Number of neutrons, that's 12 minus 6, which is equal to 6. 13 minus 6, which is equal to 7. 14 minus 6, which is equal to 8. So again, what's different is my number of neutrons. 6, 7, 8. These are all isotopes of carbon. Carbon 12, carbon 13, and carbon 14. One more example. Number of protons, number of electrons, number of neutrons. In each case, number of protons 1, electron 1. For protium or hydrogen, we have 0 neutrons, so hydrogen. Deuterium, number of neutron 1. Tritium, tritium, number of neutrons 2. All isotopes of hydrogen, what's different? So we have same number of protons, same number of protons, but different numbers of neutrons, or the atomic number, same atomic number but different mass numbers. Previously, I had written the shorthand notation of an atom, which I had written as A, Z, X, Alright, so this is a neutral atom. Where A is the mass number, Z is the atomic number, and X is the symbol of the element. Same thing here, A, Z, X, but if you notice here we have N plus, and we have N minus. N plus is for positively charged ions, which are formed when atoms lose electrons, and then N minus would be for negatively charged ions, which would be formed when atoms gain electrons. Let's look at an example of an atom versus an ion. For example, 2412 mg. 2412 mg 2 plus. Let's check. So we have number of protons, number of electrons, number of neutrons. In the neutral atom, atomic number 12, so that tells us our number of protons. Number of electrons in a neutral atom equals protons, so 12. Neutrons would be 24 minus 12. 24 minus 12, which is equal to 12 neutrons. Let's look at our ion. Protons, they do not change. Electrons, when we have positively charged ions, it means that we have lost electrons. So if in our neutral atom we had 12 electrons, the 2 plus is telling us that we have lost 2 electrons. So that would have been 12 minus 2. We now have 10 electrons. Our neutrons, 24 minus 12, so our neutrons remain the same. So what we need to remember is that positively charged ions are formed when atoms lose electrons. So in our neutral atom, we had 12 protons, 12 electrons, so that works out to be 0. In our ion, we had 12 protons, we lost 2 electrons, so that worked out to be minus 10. Plus 12 and minus 10 works out to give us a 2 plus charge, since we have more positively charged, 2 more positively charged than the 10 electrons. Let's take, for example, a negatively charged ion. For example, oxygen. Number of protons, number of electrons, and number of neutrons. Number of protons 8, given by our atomic number. Number of electrons in a neutral atom, same as protons. Neutrons, 16 minus 8 would give us 8 neutrons. In our ion, remember, for the ion, the only thing that's changing is our number of electrons. Atomic number 8. Our electrons, in our atom neutral, we had 8. In our ion, so when we have a negatively charged ion, it's telling us that we have gained electrons, 8 plus 2, so that is 10 electrons. Number of neutrons, 16 minus 8. For our negatively charged ions, what we do is we gain electrons. Let's compare. In our neutral atom, we had 8 protons and 8 electrons. That works out to be 0. In our ion, we had 8 protons. We gained 2 electrons, so that becomes 10 electrons. Overall, there's a charge of 2 minus, since we had 2 more negative charge particles, 2 more negatively charged electrons than our protons, so overall we had a 2 minus charge. That brings us to the end of our video. Thanks for watching. Hope you enjoyed it. Hope you learned something. Remember to like, share, and subscribe.